look through the solutions of the homework that I gave you last Tuesday. Okay, so when I gave you this homework, I said just to attempt questions A to F, that we hadn't done the work that was needed for G to J, but you can, I did say you could attempt them if you wanted to. And what I'm going to do is I'm going to go through what those solutions are, and then tomorrow we'll take proper notes on it. But I just wanted to show you what we do when we have a minus x. So just so you've seen it once. You don't need to take notes on it today, we'll take notes on it tomorrow, but it's worth going through it all the same. Right, so looking at part A, we've got x is less than or equal to 2 and x is an element of z, x is an integer. So we must sketch out our number line, and because we need to be around 2, I'll start up here with 3, 2, 1, 0, minus 1. You know, I don't have to have that many numbers. I could have gone to 4 here. You just need maybe 1 or 2 numbers either side of the one that's mentioned in the inequality. Now they're integers, so they're whole numbers, both positive and negative. I have a little line under the inequality sign, so I can be equal to 2. I'm using dots because they're whole numbers, no decimal numbers in between. And the inequality is telling me to go this way, that x of the values that are less than 2. So 1, 0, minus 1, and then I keep going forever in that direction, and so I colour in the arrow. Okay, so that was part A. Hopefully that was easy enough for everyone to do. Part B, I've got x is greater than 1 and x is a natural number. So now if they're natural numbers, my number line should stop at 0. Okay, so I won't have an arrow going on forever in the negative direction. Should stop at 0, should stop at 1 in fact, because 0 itself is not a natural number. So my number line starts at 1 and then 2, 3, 4, 5, etc., etc., etc. So I look at the inequality and I can see that I can never actually be equal to 1. And the arrow is telling me to go this way. I'm the numbers that are bigger than 1. So I can never be equal to 1. The first number that I could be is 2, 3, 4. In fact, it's all of the natural numbers except for 1 are defined by this inequality. And I colour in my arrow as well to indicate that I'm going on forever in that direction. Okay, so that's the integers and the natural numbers. Next we had this inequality. X is greater than or equal to minus 4 and x is a real number. So real numbers, remember, we're going to fill them in slightly differently, but still we'll start by putting the numbers onto the number line. I need to have minus 4, so let's just go 1 below that, minus 5, minus 4, minus 3, minus 2, minus 1. You'll notice I didn't even get to 0, but I know because of my arrows that I would get there eventually if I expanded out this number line. So it's fine to just have maybe 4 or 5 numbers represented on the number line. Look at the inequality here. I can be equal to minus 4, and then I'm looking at the numbers that are bigger than minus 4, and I'm colouring in my number line in this direction, and when I get to the arrow, I indicate that I would keep going if there were more numbers there. Okay, the next one here. Now, the first thing I would do if an inequality was written like this is write it the other way round. So I would say if 1 is bigger than x, that means x is smaller than 1. Just that's the way we're used to seeing it. And then I fill in my numbers on the number line. I need to have numbers that go either side, so we'll say maybe 3, 2, 1, 0, minus 1. Okay, now I've got 1 in the middle, but I could have had 1 further up here, it doesn't matter. I can't ever actually be equal to 1, and it's a real number, so I put my empty circle, and now my arrow that I drew here is telling me x is the values that are smaller. So I'm going off forever in this direction. X has the values that are smaller than 1. And that's what that looks like on my number line. And you can make that coloured in line a little bit stronger if you want to, but so long as it's visible and it's clear that you've got an empty circle on the number, everything is perfect there. The next one, we're looking at x less than or equal to -6 and its integers. So -6, and I want to have maybe -8, -7, -6. You can just go one below, two below, doesn't matter, -5, -4. They're integers, so they're whole numbers. I can't ever be actually equal to -6, and I'm looking at the numbers smaller, so I'm going this way. So the first number that I could use for this one is -7, and then -8, and then the arrow here to show that I'll go on forever in that direction. So I actually just coloured in 2 that were on my number line that I laid out here, but this is correctly done. Part F then, we're looking at 5, and again it's natural numbers. So let's get rid of the arrow on this end. Oh, sorry. I shook that a little bit. Okay, so I should start at 1, 2, 3, 4, 5. You know, I didn't have to start at 1, but because the natural numbers stop at 1, I'll just make a little bit more space and pop in 6 there as well. Okay, looking at 5, I can never actually be equal to 5, and I'm looking for the numbers that are smaller than 5. So this is a finite list. We actually even could list it out. It's the numbers, the set 1, 2, 3, 4, and 5. So I've coloured in dot and nothing in between because we're not including the decimals. Right, so for part G, let me write it down here again as well, just to take a look at it in more detail. So I was going to go through these solutions just so we can see them for the first time. Minus x is bigger than or equal to a +3. And we're talking about integers, so plus numbers and minus numbers are included. You know how if we had something like minus x equal to 3, we'd straight away know that that meant that x is equal to -3, because we could multiply across by a by a -1. My apologies. Okay, or sometimes we just say change the signs on both sides. So I'm multiplying by a -1 is what I'm doing when I'm changing the signs on both sides. So I'd like to do that here. I'd like to multiply this by a -1, and I'd like to multiply this by a -1, but inequalities are weird. If I multiply these guys by a minus sign, I have to change this inequality symbol around so that it looks the opposite direction. So I can do this and get a positive x and a -3, but instead of greater than or equal to, this then will become less than or equal to. Why is that? Well, if you think about it, when I start with minus x greater than or equal to 3, I can move sides of that inequality like it's an equal sign. So I could move the minus x over here and change its sign, and I could move the 3 over here and change its sign, and I would get -3 greater than or equal to plus x. But if -3 is bigger than x, then x must be smaller than -3. So this is just the why. Like I said, you don't need to take notes on this right now. I'm just showing it to you for the first time. So don't worry if you don't fully get this. We're going to take notes on it tomorrow. Let me fill this into my my number line. So what I'm going to do is I'm going to rewrite this. I'm changing all the signs, including the inequality sign, like this. I've changed all the signs, including the inequality sign, and I start at -4, -3, -2, -1, 0. They're integers, so I'm just doing dots onto my numbers. Can I actually be equal to -3? I can. So a dot on -3, and I'm going this way, a dot on -4, and colour in my arrow to indicate that I'm going on forever in that direction. Okay, let's look at the next one over here. So I'm just going to go straight for the shortcut. Like I said, we'll take notes on it tomorrow. I'm going to change this to a plus x, and so this guy changes around to a greater than symbol, and that becomes a plus 5. So now when I'm laying out my information, I've got 4, 5, 6. So you don't always have to have 0 on your number line. You just have to have the numbers that you're dealing with the inequality. I can't ever actually be equal to 5, and I'm going for numbers bigger than 5. They're integers, so it's whole numbers. There's no colouring in the gap in between. So the first number I could be is 6, but I could also be 7 or 8. And I colour in my arrow here, indicating that I'm going on forever in this direction. Right, and there's 2 more to do, part I and part J. And if you want to give these a try yourself, you can pause the video and try them. And otherwise, you can just watch here. So again, I'm changing this one to a plus 5. Well, actually, in this case, my x is on the wrong side anyway. So what I probably would do with this is I'd bring my minus x over and make it plus x, leave my inequality as it is. I bring my minus 5 over here and it becomes plus 5. But this time, it is real numbers. So I'm looking for numbers bigger than 5. Let's start with 4, 5, a bit squished here, sorry, 6, 7, 8. They're real numbers. I can't ever be equal to 5, so I put an empty circle on 5, and I'm going in this direction. So I colour in the line of the numbers bigger than 5, colour in my arrow as well to indicate that I'm going on forever in this direction. Right, final one here. Again, my x is on the wrong side, so bring it over here. Becomes positive. Leave my inequality alone because I didn't change signs, I just changed sides. And can I bring 0 to the other side? I can. And 0 doesn't have a sign, so it doesn't change. So x less than 0 and x a real number. So let's put in maybe 2, 1, 0, minus 1, minus 2. I can't ever actually be equal to 0, so I put an empty circle there, and I'm going in this direction. The number is smaller than 0. And I colour in my arrow to show that I'm going on forever in that direction. Okay, so now don't worry too much if you found parts G to J a little bit confusing, because we are going to take notes on those tomorrow. But I thought it was good to introduce them for the first time while we were here. Okay, thank you.